Hi, this is the second video on non-concurrent force systems. The first video shows how to calculate resultants on concurrent force systems. Um, the main difference between concurrent force systems and non-concurrent force systems would be that on concurrent force systems, all the forces act at the same point on the object. So if this was a concurrent force system, all these forces will be acting at the same point, so they could be acting at this point. Now on a non-concurrent force system, as we can see here, the forces are acting at different points. So here we have a 20 Newton force acting at this corner, a 10 Newton force acting at this corner, a 4 Newton force acting at this corner, an 8 Newton force acting at this corner, and the pivot point is point A. So this is where the object is held, and therefore, because the forces acting at different points away from the pivot, there will be a moment generated. So it could either spin in the clockwise direction or in the anti-clockwise direction. Um, in, in non-concurrent force systems, the forces don't necessarily have to be acting at the corner, so they could be acting at any point in the object, but the main thing is that they're acting at different points. Different forces acting at different points, and they're acting away from the pivot point, which is this point here. So, and the pivot point could be anywhere. So in this question, the pivot point is right in the middle. In another question, the pivot point could be at this corner. It doesn't matter. We still have to calculate the resultant on it and the moment. When we're calculating the resultant, the formula is going to be exactly the same as what we use for concurrent force systems. So I will advise you to watch the first video, which kind of explains how to calculate the resultant on a concurrent force system. But I'll go over it again here, just as a summary. So as we can see, we got the 10 Newton force is acting an angle of 180. So in the first video I explained how we got an angle of 180, and the angles are all measured from a point around about here on a straight line. So if you measure a straight line through the force, the angle is measured from here, so it's going to be all the way around. That will be 180. So it's like a straight line. The angle on a straight line is 180 degrees. This force here, the 4 newtons, if we measure our force from our angle from here as well, it will be 180 degrees all the way up to here, and then we can add on 75. So 180 on the straight line plus 75 will give us 255. For the 8 kilonewton, for the 8 Newton force, it will be from this same point as well, always from the first quadrant. It will be all the way around 180, and then down here 270. And for the 20 Newton force, that is in the first quadrant, so we just have 30. That's what we're measuring here. Good. All the horizontal components are calculated from the same formula. It's the force cos of the angle, and all the vertical components are calculated from force sine of the angle. So 10 cos 180 gives us minus 10. 10 sine 180 in your calculator will give you 0. 4 cos 255 will give us minus 1.035 to 3 decimal places, and 4 sine 255 will give us minus 3.86 newtons to 2 decimal places. So this is all what you get from your calculator. 8 cos 270 0, 8 sine 270 minus 8, 20 cos 30 17.32, 20 sine 30 is 10. Then we add up all the horizontal components and we get this, and all the vertical components we get this. This sign here, the sigma sign, is just a Greek symbol to say this is the addition, or is the sum of all this. So the sum of all the fx is this, and the sum of all the fy is this. As you can see, the sum of all the fy's is negative. So that's the horizontal component and the vertical component. So let's call our resultant F R, shall we? So that is resultant force. For, and as we learned from the first video, the formula is the square of the total horizontal, so that will be 6.285 square plus the square of the total vertical, which will be minus 1.867, and the square root of all that. So square root of all that. And if we pop that in our calculator, we will get 6.556. It's important that the negative of the Fy goes inside the bracket, so that when you square it, you lose the negative. If you put the negative outside the bracket, you will get a number here which is lower than that number, and that's not possible on Pythagoras formula. So because this is the hypotenuse, and these are the two sides of the resultant. Okay, so that's our resultant. Our resultant is exactly the same as it was for concurrent, and our angle is also going to be the exact same formula as we had. So that is the tan inverse, or inverse tan, or arctan of Fy total over Fx total. So that would be the tan inverse of minus 1.867 over 6.285. And if we put that in our calculator, we will get 16.54 degrees. Okay, that's the degrees. Good, so exactly the same as concurrent up to now. Now, the difference is in the moments. So, moments are always calculated by force times the perpendicular distance. That means perpendicular distance means the distance that makes 90 degrees with the force. So you're always looking at a 90-degree angle. But before we calculate our moments, there is something important that we need to use, that we need to remember. Any moment that goes anti-clockwise, so it goes in that direction, opposite to the clock, is negative. And any moment that we calculate that is going in that direction will be a positive moment. So positive for clockwise and negative for anti-clockwise. So let's remember that. Now, in calculating our moments, always remember, please, not to use the sign on the horizontal component. So what we've done is that we've broken each force into its horizontal. For instance, if we take the 20, we've broken it down into its horizontal component and its vertical component. So the horizontal component of 20 is 17.32. The vertical component of 20 is 10. So what we're going to do is we are going to use the horizontal component and then work out its moment, and then use the vertical component and work out its moment for each of these. But when we're doing that, we're not going to use the sign here, this -10 in our calculator. I will show you an example. So if we come here, so we're saying the force, which is going to be 10, and then we're considering this is the horizontal component of the 10. So the 10 is here, this is the horizontal component of 10 along here. Now we're considering how much distance does the horizontal component need to travel to get to point A, and it can only travel up and down because that is perpendicular. It can't rotate itself, it can only travel in that direction. So as you can see, from here to get to point A is going to be 2.5 because that is 5, and to get to point A this is going to be 2.5. So we're going to say here 10 times 2.5, and then that is going to give us 25, and moments are measured in newtons times meter because the force is newton and the distance is meter. Now, so this is going to be Newton meter. Then we have to consider, if I hold this object at point A and I tugged on it at this corner this way, is it going to spin anti-clockwise that way, or is it going to go clockwise? As you can see, if you hold it here and you tugged on it at this corner, it's going to spin this way, which is anti-clockwise. So therefore we now give it its negative sign. For the vertical component, it will not really matter because it's going to be 0 times because it has no vertical, because this is 0, so it's going to be 0, and the distance it moves is going to be times 3 because the vertical is going to move this distance to get to point A, which is going to be half of 6. So it's going to be 0 times 3, which is going to be 0. So we don't need to consider whether it's going to go clockwise or anti-clockwise. It's not going anywhere. So for the 4, which is here, we split the 4 into its horizontal, that's horizontal, and its vertical. So 4 has now been split into a horizontal and a vertical. That's the horizontal and that's the vertical. So once more we pick the number, which is 1.035, and the distance of the horizontal needs to travel to get to point A again is 2.5, which is half of 5. Now it's not always half of this, it's because in the question we have a perfect square and we know that is 5, and it's going to be half of 5, so it's going to be times 2.5. And if we put that in our calculator, we get 2.8. Oh, sorry, 2.5. I'll change this to a 5. 8, 7, 5. Now we consider, if you hold this part here and you tugged on it at this corner, you can see it's likely to go clockwise. It's going to go that way. It's going to spin out. It's not going to spin anti-clockwise because you're pulling it out against this part. So it's going to go clockwise. So we'll leave it as a positive. And remember, that's the 5. That's a 5. Good. And for this, it's going to be 3.8, 3.86, and the vertical is going to, I'll just draw the vertical in so you can see. The vertical is going to go down like this. So the vertical, what distance does the vertical need to travel to get to point A. It has to go in this direction. So you can see it's going to be half of 6, so it's going to be that times 3, and it's going to be 11.58. Now we need to consider if you hold this part. So imagine this was a square. So you can do this. You can cut out a square, and just use a pin to hold it against the wall, and just pull ever so slightly, maybe with your hand or with a piece of string. At this point, you can see it's likely to spin that way. It's going to spin round that way. So that is going to be a minus because it's anti-clockwise. Now, because this is 0, this moment is going to be 0. No matter what you multiply by, it's going to be 0. And here you don't pick the negative, you say 8 times, and you look at the distance. So this is the 8 newtons. What distance does this need to move to get to point A? Once more, that is 3, and that will give us 24. And then we now consider if you hold it here and you toggle on this corner, it's going to go clockwise. It's going to go that way. So we'll leave it as a positive. Here is going to be 17.32, and it's going to be times. So we're now on the 20 newtons. So it moves the horizontal. The horizontal moves 2.5. And that will be 43.3. And you can see if you hold it here and you pull it out this way, you pull it out the direction of the horizontal, it's going to go clockwise. So you leave it as a positive, and the 10, which is this 10 here, times, so 10 is going to move a distance of 3 to get to point A. 10 times 3 is going to be 30. And then you consider if you hold it here and you pull on this corner, it's going to spin that way, you can see. So now we've got all our moments, so this is going to be negative, so because anti-clockwise. Now all we have to do is to add all these moments up together to get the sum. That's the total of the moment. It's going to be, on the calculator, it's going to be 3.2985 Newton meters. You can check that on the calculator. So once we've got our total moment, we've got our resultant, we've got our angle. The only other dimension we need to calculate is what we call A, which is the perpendicular distance of the resultant from point A. Because there is a moment, then that means that the resultant is not going to be passing straight through point A, so it's going to be passing a displacement from point A. So if that is point A, if you draw a line through point A, it means the resultant is going to be a parallel line to that, because that's the only reason why we get a moment, a total moment. If the resultant passes through point A, there will not be a total moment. So, and we know that the formula of moments is equal to force times perpendicular distance. So therefore distance, so A, which is the distance, is going to be the moment, the sum of the moment divided by FR. So if you take the sum of the moments and you divide it by this, you get A, which is going to be, this way, that's a better A, which is going to be 3.2985 divided by 6.556, which is this, and that equals to 0.50312, and it's going to be meters. So that is the displacement of the resultant from here. In my next video, I'm going to show how to sketch the solution into here. So once we got our total moment, we should be able to sketch where our resultant actually falls, and that's why we need this distance A. We need this distance A. So I'll just do the same A here. So in this distance A. So, but these are the three values, the four values you need: 1, 2, 3, and 4 to solve this problem. Okay. So one more example. Now for this example, actually it's a practice question. I would like you to pause the video and to try and solve the same diagram, just different numbers in it. So I'd like you to pause the video at this point and then try to solve it. Once more, I've put the horizontal and vertical components in it, but I will still like you to try this on your calculator, so don't take my word for it. Try and make sure you're getting exactly the same result, and your total horizontal and your total vertical are exactly the same as what you have here, and then move on and calculate the moment. So pause the video at this point, please. So here we've got our horizontal component 6, and the horizontal component of 12, which is here, is this. So it will be like this, and it needs to move a distance of 4 to get to point A. So that will be 6 times 4, and that will be equal to 24. Now, what do you think? If you hold it at point A and you toggle on this corner, will it go clockwise or anti-clockwise? So clockwise, which is like that, that will be positive, or anti-clockwise, which is like that, negative. I think it will go clockwise, so we'll leave it as a positive. This is bigger number, so it's 10.3923, and that's your vertical component here, and you can see it needs to move a distance of 5 to get to point A. It can only move on this in this direction because that's the perpendicular distance, which makes 90 degrees here. So this would be times 5, and that would be 51.9615. Now if you hold it at this point and you toggle it up, it's going to go anti-clockwise. It's going to spin that way. It might not spin all the way around, but it's going to start to spin anti-clockwise, so we'll give it a negative. Here, because this is 0, the moment is going to be 0, because if we multiply by the distance, it's still going to come out 0, so we won't bother. This, we take the 6, but remember not to take the negative of the 6, and we say it's 6 times 5, because for this is a 6 newtons, this is 6, and it needs to move, so this is the vertical we're looking at, and it needs to move a distance of 5, and that will be 30. Now if we hold it here and you toggle here, is it going to go backwards, is it going to go anti-clockwise, or is it going to go forwards? Clockwise. As you can see, it's going to go forward, which is clockwise, and therefore leave it as a positive. And this shows us the reason why we don't pick this negative. If we had picked a negative and we said negative 6 times 5, it will give us negative 30, which will indicate it's going to go anti-clockwise, and that would be wrong. So that's why we always ignore the sign here, please. Here we have the horizontal component, which is 11.3137, and it's going to be times 4. So we're looking at 16, which is here. The horizontal component is here, and it's going to move a distance of 4, half of that to get to point A. So that is times 4, and that equals to 47.256. Now, if you hold it here and you toggle it that way, it's going to spin clockwise. So we'll leave it as a positive. And here is going to be 11.3137 times, that's the vertical, times 5, which is going to be 56.57. And because if we hold it here and we toggle it here, it's going to spin that way, we give it a negative. Okay, so here we have 14, which is that 14, and so it's going to be 14 times 4, so 14 times 4, and that will be minus 56, because it's going to go anti-clockwise. Now here, I don't know if you notice it, there is a mistake. If you put this in your calculator, 14 sine 180, it doesn't give us minus 14, it gives us 0. So this one is 0. And if we do 0 times the distance, it's still going to give us 0. Okay, so if we add all this together, it's still this is 10 take away 6, this is about 4, and then take away 11, so it's going to be minus 6.9. so the answer is correct, it's just a typo here, sorry for that. And if we add all the moments together, we get minus 65.274. Okay, our resultant FR will be the square of this plus the square of this. Remember to keep the negative inside the bracket, so the minus. Important to keep inside the bracket. Then square it, and then do a square root of the whole thing, and that will give us 20.51. Okay, our angle will be the tan inverse of minus 6.922 over 19.314, and that gives us 19.717. And our resultant times the distance, perpendicular distance of our resultant, which we'll call A, the total moment, which is that. So if we put numbers into it, we have let's say we have our A will be equal to this. Let's put a formula first before we put numbers in, and that will be equal to minus 65.274 divided by 20 which will be 3.180. So these are the four pieces of information we need. Sorry, this was total moment. Okay, these are the four pieces of information we need. We have our total moment, we have our resultant, we have the angle of our resultant in degrees, and we have our distance in meters. And with that, we can find out where the solution is going to be. Okay, I hope you understand that. Let's try our hands on a self-assessment question. So please pause the video at this point and try your hands on this. It's a similar sort of question, it's just that it's not a square. This is more of a real life part. Thing to note is that when you have a force directly on the pivot, there's no distance, so the distance is going to be 0. So take note of that. Whenever you have a force on the pivot, the distance is going to be 0. Okay. Welcome back. So here we have a blank table or partially filled table with all our horizontal components, all our vertical components. So 18 kilonewtons. Now these forces are in kilo, so all the forces are in kilo, and therefore the distances are in meters, and therefore our moment is going to be in Newton meters, kilonewton meters. So kilonewtons times meters. So here we have 18, which is that one, 18, and because this is 85, remember the angle from here, so we're looking at this angle here. Looking at this angle here, it's going to be 95, and that's why we use 95 here. So this angle is going to be 90 because it's vertical. This angle is 15, it doesn't change, and this angle, because this angle is straight on the axis, is going to be 0. So the angle of, and whatever angle you use for horizontals, we have to use for verticals. So that's where we got all these angles: cos for horizontals and sine for verticals. So force cos angle, and then force sine angle, and it gives us all these results here. Now for the moments, once more we're taking the component here, and we're multiplying it by the distance. So for the 18, the horizontal of the 18, which is this, we're looking at horizontals. What distance does the horizontal of the 18 need to move to get to point A? And that will be 15. So that will be this times 15, and that will be 23.55. Now if you hold the part here and you pulled it like this, it's going to spin anti-clockwise and not clockwise. So therefore this will be negative. As you can see, you can cut out a shape actually. You put your finger here or pin, and then tug on it with your other finger, another finger, or a piece of rope, and you can see it's clearly going to spin anti-clockwise, so it's negative. we have 17.93, which is this, and the distance it needs to move. So we're looking at the vertical of the 18 now, which is this. As you can see, the vertical of the 18 can only move left or right, and to get to point A, it's going to move this distance here, 5, because it's moving from there to there. So this will be times 5, and that will be 89.5. Now, once more, if you hold it here and you torque upwards ever so slightly, it's going to go anti-clockwise, so that's a negative. Here we have 10, and how much does 10 need to move? So the 10 Newton forces here, and how much does it need to move up or down perpendicularly to get to point A? It needs to move 10 meters to get to point A. And that will be 100. Now, will that go clockwise or anti-clockwise? If we hold it here and you tugged on it here, you can see it's going to go counterclockwise. It's going to spin like that. So that will be a negative. Okay. The vertical is 0, so it's going to have a 0 moment. This is going to be 14.49, the horizontal component, and we're looking at the 14. We're looking at the 15 kilonewtons force. So the horizontal component is going to be like that, and the vertical is going to be like that. So this is, now here we have to consider the horizontal component. How much does it need to move up or down? This is the horizontal now, up or down, to get to point A. Now you can see it's already on the same line as point A, so it can't move up or down to get to point A. It's already there, so the distance is going to be 0, and therefore the moment is going to be 0. For the vertical, on the other hand, it needs to move left or right. It can only move that way, perpendicularly. So to get to point A, it moves 7 to get to here, and then 5 to get here. So it moves there and there. So it's actually moving by 12. So it's going to be 3.88 times 12. And that is going to be 46.68. Now, if you hold it here and you tugged on it like this, is it going to go anti-clockwise or clockwise? You can see it's going to pull up and go that way. So it's going to be a negative. And because that is 0, this will be 0. Then 35. So we're looking at the 35 kilonewton force, which is here. But you see the 35 kilonewton force is on point A, so it can't move back or forth to get to point A. It's already on point A, so the distance has to be 0, and that is 0. Okay, so the total moments, the sum of the moments is going to be, add all these up together, and on your calculator I got, or rather my students got this number, and that is in kilonewtons meter. Okay, our resultant is 22.92 square plus 56.82 square, these two, and the square root of that, and that equals to about 61.2686 kilometers. The angle is the vertical, always the vertical please. Put that in our calculator, we get divided by 22.92, which will be 68.03. And then resultant times will be equal to total moment. So therefore your A will be equal to minus 4.2392 meters. So this is it. These are the results we need. Our total moment, our resultant, our angle, and our perpendicular distance.